Hey guys, it's Jason Webb. This is the show that highlights local business leaders and the movers and shakers of Minnesota. Welcome to Minnesota Made. All right, guys, welcome back to the Minnesota Made podcast. This is a Zoom call with Brian Iverson. And Brian creates a very unique product for the construction industry called TStud. And he's got some really cool videos on his website that explains it quite well, but we'll get it a firsthand explanation from Brian here in a little bit. But before I forget, the website is tstud.com. Brian, welcome to Minnesota Made.
Hey, I'm in Minnesota even. Okay.
Yeah. Yeah.
I truly appreciate being here. I'm excited for the next half an hour or hour, however long you give me.
Yeah, well, I'll be here as long as you are. And Brian, you mentioned that you're from Minnesota. This is a Minnesota-based company. And before we get into what TStud really is, you want to give me a little bit of a backstory, where you came from, where you grew up, what your childhood was like, and the path you took to get to where you are now, being the owner of TStud.
Okay, well, that'll take an hour. Let's see, grew up on Selby and Dale in St. Paul in the 60s, and born at St. Luke's Hospital. Parents are farming people, and so they.
So there were farms in St. Paul back then?
No, they moved from Hawley and Hitterdal, and in northern Minnesota, potato country, okay, and moved down to the cities to start over and start from fresh. And my dad ended up going to work at Waldorf Paper Company for 35 years. Oh. So he started out there. We started out in life, Selby, Dale, Galtier, Van Buren, all those streets in the Midway area. And then we ended up moving in 1970 out into Forest Lake. Gotcha. So northeast of St. Paul. And so I graduated in, I'm going to date myself now because I'm not afraid. I graduated in 1978 from Forest Lake.
Okay.
And first real job was doing drywall work for the neighbor. And so I started hanging sheetrock when I was 14. Probably why I had back surgery in '88. I've done a lot. When working with him, ended up in construction, ended up framing lots, ended up doing remodeling work. I did 1 year, we did 300 remodel jobs. I was young, I just enjoyed it, right? You go out, if somebody else isn't going to bid on the job, well, we'll do that job. Well, some of the jobs we found out we were the only one bidding on. That's because nobody else wanted them either. So I ended up going to school in to Anoka Votech, now Anoka Community College, or Anoka Hennepin. I don't remember what they call themselves now. So I went for architecture, engineering, civil engineering for a couple of years. And so I graduated from there in '81, so since then I've designed 750 projects that have been built, okay? Lots of people design things, they never get built. I just happen to count the ones that got built. So it's around 750.
Wow. And
so I'm a journeyman carpenter, journeyman sheetrock taper. Yep, had back surgery from all that crap. So I was the guy schlepping around all the studs on the job. And you just keep on going through life and you keep on selling things and helping people. And I became a realtor along the way and a developer, obviously in 2006. So 2008, they say real estate all fell apart, blah, blah, blah. Mortgage rates did this, did everything. My first real estate transaction in 1984 was 13% interest, and the seller paid either 10 or 13 points to buy the rate down to that. Okay, so interest rates at 2.5, you know, people qualify for lots of money today. They qualify for mortgages through the roof because interest rates are cheap.
Yeah.
But if interest rates went up to 5%, they'd only get 1/3 the house. Okay, so, but so I learned young to design, build. I became a certified energy auditor for NSP in 1981. And so I've been able to calculate for us all of our energy efficiencies, how efficient we are, what do we do, how do we clear a path forward? And but an interesting date is March 14th of 2006 is when the media said for the first time that gas was going to $4 a gallon. Okay, so at $4 a gallon is real estate's D-Day. That is the first day, because I wrote the day down because I thought it was going to be significant. So I developed most of Isanti north of Minneapolis. And what I saw happen immediately was people had to start making a decision after that date. And I mean, it was immediate because most people live, I'm not going to say paycheck to paycheck, hand to mouth, however you want to say that,
Right.
but they don't have any extra money to go spend. Well, now they're spending triple the amount of money on gas. They can't afford gas because they have to buy milk for the baby. Okay, so they got to provide food for their families. So they had a choice to make. And this is 2006. And this is when we started seeing the wave. People had to let their houses go in the countryside, farther away from the city, because they had to get closer to the job. So they left their houses go because they had to provide milk for the baby, and they started renting apartments in the cities. So as the economy was starting to falter and go downhill like this, we saw everything crumble. We saw all of the bad real estate transaction, mortgages, real estate deals, you name it. They were all coming back to bite everybody in the butt because they thought it would run on forever. But that price of a barrel of oil went like this, and nobody could afford the gas for their cars. So that's when it all started. So that was I went down like everybody else, but I'm the first guy who went down. Then I ended up working for a bank out of Wisconsin and tried to save their soul, and got to see more stuff going on the banking side of things. So I had 3,000 properties in my portfolio. I helped them sell 1,000 properties in 26 months and fried my gourd. I mean, you just can't. It was an ugly time.
Right.
So I decided to get clearly out of real estate as a whole, and I ended up going into the gas and oil industry. So in the gas and oil industry, frac sand, did this, did that. I've developed 3,000 lots. I built 30 miles of roads. Okay, so I knew all about moving dirt. So I ended up getting hired off because I ended up with a crazy skill set in the gas and oil industry besides. But I got hired off from a company out of Brisbane, Australia, and I helped them turn fly ash, the waste byproduct of a coal-fired power plant. Hold on. So this just happens to be fly ash. So when you take coal, big chunks of coal, and you fire it, you burn it, it actually turns into, it's just a powder. I know you can't see that, but it turns into powder. And so what they did is they turned that little powder into little ceramic beads for fracking. So, and I know you can't see these, but these things crush at 14,000 PSI.
Wow.
Well, that was a crazy deal. So sitting up in Stanley, North Dakota in the gas and oil industry, putting this together with the Beulah coal-fired power plant, trying to secure fly ash. And this is just fly ash and a little bit of clay and a couple of other things I can't tell you. They got these ceramic beads that they use for fracking to go. But March 15th of 2015, I was having coffee with some people, 8 o'clock in the morning, 9 o'clock in the morning, I don't remember. And the snow, my favorite line for North Dakota is, when the wind blows, there's no place to hide. And no lie. I know all my friends say, yeah, but when your dog runs away from home, you can still see him running 3 days later. All right, so there's my humor. Anyway, so I thought of the TStud I thought of the original version of the TStud. At 9 o'clock in the morning, I was home 8 hours later. And if anybody knows, that's a 9-hour drive I did in 8 hours. I was so excited. I figured that if anybody was crazy enough to think about all of the advantages of how I did the TStud, they were going to be as crazy as me. So it took, we filed the first patent in July of 2015, and it took 24 months to get the patent almost exactly.
Wow.
And then I figured out I didn't have enough in the first one. And so we filed what's known as a CIP, a continuation in process. Filed the CIP, got that in September. And so that's how we then ended up blocking out people out of our space. So the TStud was born. There's actually 34 patents in the space. And we're the only ones who thought of turning, all the other patents are the same width of a 2x4 or 2x6. Everybody stayed 1.5 inches wide. Well, I can tell you, because I had to build them, they're only good at driving your fish house down the road at 35 miles an hour. At 35 miles an hour, they buckle. All 30 of them, okay? That wind load, they can only stand 35 mile an hour wind load. But when I turned that member perpendicular in the patents, and we did all of our testing, this is what gave us our strength. So 2x6s, and like every other stud known to man, in a failure mode, when you load this load and you push on this so hard, so all your floors above it are all resting on your stud, this stud actually deflects in the x-axis out of plane and snaps. That's how you fail it. But when I turned that member perpendicular, I stopped the ability of the stud to deflect in either X or Y. So we actually only fail in Z, which is fiber upon fiber going straight down. So this is certified. A 2x6 is 2,200 pounds for the most part, sometimes 24, sometimes 1,600 pounds. So it just depends upon the quality of the fiber of this.
Okay.
But we crush at 8,600 pounds.
Wow.
That's what we crush at. So we actually crush the plate, right? So if that's your plate, we actually crush that plate at 3,600 pounds. So our strength value proposition is through the roof. We did all of our testing at 24 inches on center. We're hurricane compliant. We're earthquake compliant. We're certified for use in 5 stories in the United States and 6 stories in Canada. So we're code compliant all over the place, but now I have 10 patents filed in the US, 5 in Canada, and 28 other countries. So
wow,
there you go.
Yeah.
How's that in a nutshell?
Yeah, that's pretty good. Thanks for that, Brian. And for those of you that are just listening and aren't watching, what Brian was holding up and comparing was a typical 2x6 versus the TStud. And Brian, let me know if I described this correctly. The TStud is basically, it looks like 2 1x3s, one turned vertically, one turned horizontally, and they're connected together with a dowel of some sort, but there's a space remaining between the 2 1x3s that allow for like insulating and increasing the R value of the product. Does that sound right?
Okay, I'll give you a B plus.
Okay, all right.
Okay. So hypothetically, we took a 2x6,
Yep.
and we slit it in half, and we made 2 2x3s, not a 1x3. They're 2 2x3s.
Okay, yep.
Okay. And so this is the first product. This is certified for an R value of 19. So most houses, half the country, 2/3 the country require about half the country require that all buildings get built, houses get built with 2x6s, not with the 2x4. So we took that 2x6, we slit it in half. We built a truss through the middle of it made out of dowels. And then we put in a polyiso foam. So we used, we're the first ones to make a product out of a blowing agent in the foam known as HFO, hydrofluoroolefin. So it doesn't burn. I don't know if you can see it. I got one up here that's burnt. It passed as a Class A fire rated wall stud. Okay. So it just doesn't burn. Right. And so this is we're certified for 16 feet tall with this product. And this product was originally made for if a builder was using bat insulation to easily stuff in bats, similar to what they do in 2x6s. So 58% of all builders use a bat. The other builders, besides the people who use horsehair, bales of hay, foot tires, I don't know, skip all those people. That's 5%, okay? But everybody else does a blow-in or a spray-in product into that wall.
Okay.
And so then the Bare Naked TStud was born. Bare Naked meaning it doesn't have foam in the middle. So the Bare Naked TStud is what we're producing today. And so these are certified to hold the same weight. Because we don't have a foam in them, they're certified to 12 feet tall and in a wall height. So that's 98% of all builds. So that's the 5.5 inch. And then we have a 7 1/4 that's certified. This is certified to hold 7,400 pounds on a 2x8. So these things are strong. They're certified for 16 feet tall. And then we have pole barn manufacturers that want these, and they want to use this as their purlin. And so we'll make them for them 16 or 20 feet wide. They'll nail this on for the purlin, and then the spline that we call it, this becomes the interior wall. It's already pre-attached, pre-built, it's already there. And so they don't have to build another wall in front of it to be able to have a wall on the interior. So, but
yeah.
Anyway.
That's pretty cool.
Yep.
So where do you think this idea came from? I know you got excited, you hurry up and drove home, but do you think it's a combination of working in the framing field and then working, I think you said you did some, I don't know, home efficiency energy testing at one point in time in your careers. Where did this all come from?
I have no clue. Like literally a gift of manna. Like no lie. I have it's so far out of the box, right?
Yeah.
Never thought of it, never nothing. And you're just sitting there. Okay. So that's what happens with people who invent things, right? They see something and all of a sudden their mind just like that clicks. And all of a sudden they're like, wow, maybe not, right?
Right.
So I was fortunate enough that I had the wherewithal to figure out how to file the patent, how to do the testing. I already had I call it a crazy skill set, but I have a crazy past, right? So I have enough followers, friends. I had enough in my bucket to say, okay, this is what I got to go do. And so obviously there's been a lot of money invested. We have 110 shareholders about in total. So we now have a manufacturing arm. Let's just put it this way. We have over 10 million invested to date to get this far, but look at what you got to invent. Okay. Yes. So if we're trying to communicate to anybody who thinks of anything, I'm going to tell you that most of the time you think of something, and I'm looking here, I don't care what this is, whatever this is, you invent a product that makes this product more efficient. Okay. So you're just one piece of this product. Mm-hmm. It's a horse of another color when you invent a product that has never been built before. So now we have 5 product lines that have never been built before, and all the patents that you need to have in order to go make that product, that's unheard of. Okay. In the entire space. And then you have to, so your patent is worth X dollars. Then if you can figure out how to monetize that patent, you need to figure out how to go make money with it. Okay.
Right.
So you gotta figure out how to make it, how to build it, how to pass all the code tests, how to pass this, how to go to UL, Underwriters Laboratory, and get their blessing, which that's a whole nother story. And so you got to go through all of these gyrations every day. Okay, left brain, right brain, right? Your right brain is thinking, oh, I'm going to have a glass of wine at 10 o'clock at night. And the left brain wakes up and says, hey, I'm going to get out of bed at 4 a.m. You know it. Don't you dare have that glass of wine, because at 4 o'clock in the morning, your left brain's going to turn on and try to solve for something. I have no idea, but that's what happened. Okay. So in order to figure out how to mass produce this, I had to figure out how to make dowels. Like, how do you make dowels? How do you make them pass? How do you make them? How do you make them? What do they have to look like? What's the adhesive that you have to use? How do you get adhesive that's code compliant? And how do you make them dowels 6.5 inches long, or however long that they're going to end up being? How do you make them fast? How do you make them? How do you make them? Let alone, how do you load them? Right. So we load. I had to go to the food industry. So you know what this motion is? That's your Panera bun or your Olive Garden bun that you love so much, going in a baggie. Okay. So I had to go to the food industry in order to figure out how to go fast. And the optical eyes that they use, look at that. They look at the Olive Garden bun. They can see it if the flour is mixed into the bun at the right consistency. And if it's not, it's got to eject that bun, grab the next bun, and get it into the baggie at 180 a minute.
Jeez.
Well, in 12 months from now, we will use $1 million a day. So we had to invent the technology, but right now we're making $15,000 an hour. Okay, 15,000. But I had to start out at 2 machines at around $1,000 each. So last year through COVID, not a fan of COVID, by the way, because we got booted out of Canada because they wanted to even need a quarantine in place every time we went over. I'm not doing that. So we're now down at, we're manufacturing actually in Newton, Iowa. So I drive to Newton every other week from the home office here. So the you got to make dowels. You got to get the adhesive into the hole. We had to custom make a nozzle that has a reed valve on the bottom of it, because the adhesive you buy is so expensive. You buy it by the gram. So you got to put it in the hole, but when you come out of the hole, you don't want it to drip. So we had to invent a little reed valve down at the bottom of the tip, so that when you pulled out the last time, it doesn't drip. I can tell you, there's one thing after another, after another, after another that you have to do in this whole entire process, and you're constantly inventing because nobody's ever done it before. So if there's somebody that's listening to this that wants to invent something, I'd be willing to sit down and chat with them and tell them all the process that I had to go through.
Right.
But I can tell you there's been many sleepless nights. That's a fact.
Yeah, it sounds like a huge pain in the ass. Were there any point in time where you're like, screw it, man, I'm done with this? Or
no,
I'm just going to sell it and for whatever I can get out of it, and that's it, I'm done?
No.
Stuck to it. That's good.
No, but you got to understand. You have to understand why. Okay, so at some point you're going to ask me in this podcast why. Okay, so I know you have an agenda. You have questions you already probably got listed out that you didn't send to me. Okay, so you keep going, but at some point you need to ask me why.
Okay, let's do that. Why?
So I thought you were going to wait.
Mm-mm.
What do you mean?
I have no agenda when I do this, man. I just wing it.
So, you're winging it?
I wing it. I just try to focus on what you're saying, and we go where we go where you go. So let's talk about the why.
Okay, let's leave politics aside, okay? Because I'm tired of some acronyms, okay? So I'm a conservation guy. I'm an ecology guy. Okay, so I know that when we drill an oil well, you get natural gas for free. Natural gas is cheap because it's a byproduct when they're drilling a hole in the ground. Okay, natural gas is cheap. Electricity is super expensive. To heat a house with electricity is 3 times the cost of natural gas. I've always been concerned at how much money here, after living through 2006, 7, and 8, and knowing the real reason why everything crashed, okay? If we could make things more energy efficient, including your house or the building that you're in, and that we call them operating costs, if you can reduce your operating costs that it takes, then you might have a little bit of extra money to spend on your children. Okay,
Right.
so I have known since 2000 and no, sorry, since 1981. I have known since 1981 that this is called the bridge, and this is not the bridge over troubled waters. Okay, this is just the bridge, right? So if this is the outside, this is the inside. Whatever happens out here, let's say that you're in San Antonio, Texas, you're in Phoenix, Arizona. It's 115 degrees out because we're just going to blow things out of proportion. This side of the house is baking, right? But you're over here in your nice little comfy shorts and you're trying to maintain 70 degrees. So you get this 40-degree temperature swing. I'll tell you what, when you're down there and you're trying to hang a picture on the wall, you don't need a stud finder, because all you got to do is put your hand up against the wall and you can feel the heat barreling through. Okay. So every house built, every building built, they're 16 inches on center framing. 24% of the wall is made out of studs. The R value, the resistance value, the insulation value of that stud is 6. The insulation is 19. So 24% of your wall is in R value, that's 1/3 of that, which allows the heat and the cold to come through like it's a bridge, right? Straight through, it's a bridge. And that's affecting your heating and cooling bill over here. So I've always thought, how do you unhook that bridge, right? Normally, normally you put your sheathing out here and you put a piece of foam on the outside, and that's what that becomes, is you have a continuous insulation on the outside. But putting that thing on the outside is not a cheap endeavor. So when I said, we're going to take this away, because this is how simple this is. You take this out and you install this, right? So now you have a break. This is called a thermal break. So we've broken the ability of this heat to pump through that wall, because we added a nice insulation layer like your winter coat. We stuck a winter coat in the middle here to help keep you warm or cool on this side. So we put this break through the middle, and I've always been trying to think. So when you think about this and you do this, we reduced heating and cooling bills. We've already proven this. We got 500 structures out there. I have no idea. Just by doing this right here, we cut the heating and cooling bill by 20%. Wow. By 20%. Okay. So I'm going to give you some crazy math throughout. I'm going to give you a crazy little number to keep in mind.
Sure.
So I've always been trying to figure this thing out. Okay. I could never figure it out, but we also survived the first oil embargo days, where we had to go through in 1982, we had to go from a 2x4 wall to a 2x6 wall in order to make the wall assembly have more R value insulation. So we went from an R value in the cavity of 13 to 19. The cost of that was $2,000 back then, but interest rates were 13% interest. Okay. Well, that's $100 a month. I don't care. I don't remember. It was a lot of money, whatever that math ends up being.
Right.
They couldn't afford it. They couldn't afford this. I know plywood was only what, $8 a sheet. Studs were, $2 extra. They made the world's craziest studs. They made the first finger joint studs back then, but nobody could afford it. It's not like today. Interest rates are 2 or 3%, and $100,000 loan is $100 a month, whatever the math is. So it's cheap. But then it was super expensive to go do, and nobody could afford it. So you lost 2 inches of floor space on your whole entire structure. You lost 2 inches of floor. Well, we were doing 884 splits for entry-level people. We were doing 960 splits. But in order to make the bedrooms at least 10 by 10, you had to make the house bigger. So we went from 960 to 1,040 square feet all the time. Well, now nobody could afford the extra square footage. So we were darned if we do and darned if we don't back then. So I had all these rumblings sitting in the back of my head. And when I thought of the TStud, I thought pull it off. I'm thankful I had enough to pull it off to get to today, because we have a crazy fun story.
So you mentioned some crazy numbers or crazy math. Was there, in addition to, and it was in reference to reducing the heating and energy bill or electrical bill by 20%.
Yep.
Was there more to that story?
Yep. Okay. So the National Home Builders Association and the United States government through energy.gov and I don't remember the acronym, AEI, the Energy Information something, where they bring all this data in. They do a study every 10 years where they calculate how much every house, they do it on housing. Okay. So they calculate how many BTUs it takes to heat and cool the average house in the United States. Okay. So we're qualified for Canada too. So I don't know their math, but I'm sure it's similar to ours. Okay. So they came up with a number, and they have studied this for the last 60 years. So every 10 years they do a study, huge study. And they came up with that we use 34.1 BTUs per square foot. Okay. I think this is in thousands, if I remember right. So 34.1 thousandths per square foot. So the average house in America is 2,450 square feet. So we use something like 67,000 BTUs to heat and cool a house in North America, whether it's built with 2x4 walls, 2x6 walls. If it's an existing house or a brand new one, they study everything. And then they take a look at how much energy do we end up using for those structures. So over the last 60 years, we've gone from like 54.1 down to 34.1 on average. That's what we end up using. So in simple math, I can tell you that just by doing this and getting having a thermal bridge or thermal break through the wall assembly, we save 20% on average just to do this. And these don't cost any more money today than these, because there's 30% less of these than these, and that pays for us. So we actually don't cost any more money to make a structure 20% more energy efficient. So it's a fun story to be able to tell. But we're saving 16,000, so 16 million BTUs in a year. Okay, that's money. Yeah. That's money. That money lasts forever, by the way. That's the annual, right? Mm-hmm. And we go to sleep in the wall, so there's no maintenance required. So we don't sell studs. We're strong. We're super strong. So we sell energy efficiency. So our story has morphed from being the world's strongest engineered wood product known to man to now we just sell energy efficiency, and some huge partners are coming alongside of us to make the world's most energy efficient structures for less money than what we're building today.
Yeah, it seems like a no-brainer. The surprising part to me is that it seems, I mean, you're sticking some labor into making a TStud and some costs as far as a dowel and the adhesive and so on, and inventory and shipping, but it doesn't cost the end user consumer any additional money to buy that product versus a 2x6. Well,
okay, so
or did I mishear you?
We've had to adjust our distribution. So part of, if anybody wants to invent something, you got to figure out how to distribute it across the country. And the challenge that we've had so far is that we're not just a stud, right? So the sound transmission rate through this is, well, we call it +6. So we make your hotel and motel wall 20% quieter. And I can tell you, so here's a funny for you, only 2 times ever in my whole career have I ever got a big smile on my face for what was going on the other side of that wall. Okay, 2 times. Okay, but all the rest of the times, I don't want to know what's going on in that room. I want it to be quiet. So we just because we got that thermal break in there, we make walls quieter, so we get a thermal break. So we have that's a good gift that keeps on giving. So, all right, that was my humor. All right, that was way a tangent. Anyway, okay, I'll get back to reality here.
Yeah. Oh, well, back to the cost question. Does it cost more to get a TStud than a regular 2x6?
Well, the 2x6s are obviously, today is, what's today? Is today the 9th, June 9th? I'll put a date in here, June 9th, 2021.
Yep.
Okay. Lumber is through the roof, right?
Right.
Lumber is super expensive. How did it get to be expensive? Well, you got COVID. COVID affected, there's still four sawmills in Canada because the Inuit are really the natives, are the native band people, the originals of Canada are greatly affected by COVID. And there's still 4 sawmills across the north that are shuttered today. Cedar, there's 2 main producers of cedar in Canada. One guy got shut down, one gentleman got shut down of over harvesting in 2020. So he's not producing at all. He was the biggest producer of cedar. So cedar is like 6 times the cost today of what it normally is.
Jeez.
Interest rates are super low. Money is easy to get in back again in housing. People qualify for lots of houses. People are getting paid enormous sums of money. They don't need to drive to work. A lot of these people don't drive to work. They work out of houses. You got 2 Zoom rooms going in. I built a Zoom room for us. We don't have an office per se in an office building anymore. We have 9 people across the country that work all remotely. And so the manufacturing process is we go out, we buy 2x6s today at the same price that everybody else does. We actually buy 2 2x3s. 2 2x3s, they take just as much labor to make a 2x3 as a 2x4 as a 2x6, because it's lineal. It goes through the sawmill planer at the same amount of time as the 2x6. So they're making more 2x6s today because our housing starts are 1.7 million on average right now instead of 1.2 million on average. So there's 500,000 more houses being built in the countryside today that have never been built before. And our infrastructure, all of the sawmills, all of the plywood, people, there's not enough people to go build 1.7 million. We don't have enough fiber. We don't have enough of this. There's not enough ships coming in because of COVID. You got every challenge known to man going on all at the same time, and the price is through the roof. But as the price of lumber comes down, and oh, by the way, it took a dip down today. So write the date down. It took a dip down, so our price went down a little bit. So as the lumber price goes down, so do we, because we buy the same lumber. And so if you're in 750 miles of in the Midwest, if you're in the Midwest, we can ship to you to your job for free as long as you're not on gravel. So we ship out every day. We just don't tell anybody how busy we are. But we ship out every day across the country, and we ship out these for no more money than these because there's 30% less. So it costs us 30% more to make this out of this, but there's 30% less and your structure's stronger. So are we more money? Yes, we're more money. If you want to buy 1 and 1, we're more money. But
the long-term savings will more than make up for it.
We're the gift that keeps on giving, and we're a good one. Yep.
Yeah. You won't ship on gravel. Why not gravel?
So trucking's been interesting. When we put together units, we put them inside of a van. So we put them in enclosed vans. We put them on the side of a truck, on an open truck. We ship however we possibly can. But a lot of those trucks, they just tell you flat out, we're not going to go get our truck dirty driving down a gravel road in order to figure out how to get to you. And some jobs, they don't have a Pettibone or a Low, or they don't have a Bobcat there to unload. So then it has to go to a warehouse to unload in town, and you got to go pick it up. Right. So every place has a challenge. Alaska, we literally have people who drive down from Alaska to pick up their product to drive back to Alaska. And our payback in Alaska is one Super Cub flight. So they load up a Super Cub full of TStuds. They go out there, build their house out on the prairie somewhere off the grid. And And when they want to heat it, if they don't heat it with wood, they got to bring propane out. So their 100-pound propane bottle goes into their Super Cub. Boy, is this a plane, a bomb ready to go off, right?
Right.
But we've had people who now only fly out 2 times a year instead of 4 times a year. So our payback was 1 flight. That's how bad that they wanted TStuds.
Wow.
That's how you know the benefit of what you're doing. It works, right?
Yeah. What kind of feedback have you gotten from?
We have builders who keep coming back because I'm not going to say we created the perfect mousetrap, but we just teach them, take this out, push us in. And other than the fact you got to cut your header different, there's no difference. So it's quite simple to use. Last year we won, not we, but the builder. So another little handoff here, Sustainable 9 Builders. They're out of Minneapolis, super sharp, smart people. They build super energy efficient structures. So they got the R19 TStud as a frame, so a bare naked, and then they did the foam in the field themselves. So they won the Department of Energy's award last year for America's most energy efficient structure. And it's in Minneapolis, super people. I've been down there a few times. 3,500 square foot house. 4 people live in the house and they have 2 dogs. So I always say as my disclaimer, I don't know how many geriatric cats you have, so you can't control how many times you open and close the door.
Sure.
But their 3,500 square foot house, they pay $50 a month for gas and electric.
Wow.
So that's washing clothes, drying clothes, running the cooking, running their, they have a gas fireplace. They have a gas stove. They're super energy efficient, but $50 a month. They had in Minnesota, we do things by known as HERS scores, HERS ratings on energy efficiency. Their energy efficiency, so like an average house in America has a HERS score of 100. We have lots of them across the country at 40. Theirs is 0.8, negative 0.8. So in order to get to 1, they did solar panels, they're doing everything they possibly can get to 0 for energy, because they don't want to be a demand on the grid. Sure. And Sustainable 9 builds quality structures just like that. So do other ones. Solid rock solid construction up here in Blaine. They have several structures going now. There's builders in Wisconsin. There's builders in New Jersey. I can't rattle them off. Colorado, a bunch that use us, that because they don't want to leave a carbon footprint. Okay, so we're actually a tangible product, right? So we actually save money. You use us, you save money for your client, or if you're going to build it yourself, you save money every month, every year, forever, because you're reducing the demand on the grid. So you're reducing our carbon footprint that it takes to operate that structure. Yes. So we're a tangible, not intangible. We're not monopoly money. We're real money. So we're a tangible operational carbon footprint reduction.
That's awesome.
Say that 10 times.
No, I'm not even going to try it once. I got 2 quick questions on this. Can you tell me again the numbers, the R value on a regular 2x6 versus the TStud? And also, because the TStud is stronger, and there's building codes you got to deal with and so on. And I don't know exactly, when you frame a house with 2x6s, is it 24 inches on center? But if your product is stronger, would it justify, going further than 24 inches?
No. So plywood is your limiting factor. Okay. So plywood is only good. Drywall is only good at 24 inches on center.
Oh, okay, got it.
Okay, and then you have a wind load, right? You have a wind load that's you always got to design for that, in Minnesota anyway, for that inline wind, right? Mm-hmm. You design for an inline wind. Heaven forbid there's a tornado, but we have a few a year. So you design for the worst case scenario, which is that wind load. So when you put your sheathing on your wall, you need so many nails in the sheathing, put into your fasteners to stop your wall from racking. Okay. Yep. Okay. Yep. So the R value, the resistance value through this is 6.1 actually. A 2x4 is 4.3. Okay. This is, it depends upon what that insulation is in that wall cavity.
Yeah.
Okay, so if this is cellulose in here, the R value is 11. If this is spray foam, typical wall spray foam, we get to a 16.
Okay.
The R19 that will be back manufacturing this fall. And just to let you know on the invention side of things, to put out this liquid, right? So this liquid is grams per centimeter. No foaming gun has ever been made to go into a continuous foaming line that has ever put out grams per centimeter before. It took 1 year to build that gun through COVID.
Jeez.
1 year, right? So we now have a gun that is going to lay out grams per centimeter. So they call this a 2-pound foam, but that's 50% air. And so some people are going to say, well, what's the global warming potential of that? So Honeywell, okay, Minnesota-based Honeywell, they invented a blowing agent called HFO. So we went from formaldehydes in the 70s, got rid of formaldehydes, and they invented a blowing agent called HFC, hydrofluorocarbon. So carbon makes it sound like it's burnt toast. Okay, so carbon, you burn your toast. Okay, and then Honeywell invented HFO, hydrofluoric olefin, which is a new style of blowing agent that only has a global warming potential of 1, 2, or 3 or something. So formaldehyde global warming potential of, let's say it's 10,000. HFC has a global warming potential of 1,300, and then Honeywell comes out with HFO, which is global warming potential of, let's just say it's 3. Okay, so make sure that if you're ever going to put spray foam in your wall, make sure that you use HFO blowing agent, and that's all that we do. There's no off gas, no crap, no nothing. But stick it in your wall, there it goes, and it doesn't burn. So there's a benefit. I've seen 2 houses get burned down. One of them was mine. Okay, so I'm really fire conscious, making like a lot. Okay, so did I answer your question?
Yeah. So it's stronger. It's more energy efficient.
Yep.
It doesn't burn.
Well, this burns. This one, the foam doesn't burn.
Yeah.
So don't say it doesn't burn.
Okay.
You can't. Yeah.
Well, yeah, it definitely seems like a superior product, and it seems like it's you guys are kind of, in the early stages of all this. Where do you see all this going? I mean, when you look in your crystal ball, I mean, what are your hopes and dreams for TStud, or what do you think the potential is here?
Okay, so we have a building coming up here in Ham Lake, 5,000 square feet. And we're 20% less. I got to remember who's going to listen to this. So everybody's got to remember the date today, right?
Yep.
So we're 20% less than 2x6s today. And they're doing the 7¼ inch, 16 feet tall on their 5,000 square foot commercial building. We're 20% less than going to Menards today to buying a number 2 stud. We're going to ship these to the job. So they're going to insulate. So the 20% that they save, they're going to insulate. Okay. But then what we did is we made it a little bit better. Okay. As maybe you don't know, OSB plywoods are through the roof today. OSB today at Home Depot down the street is $54 because I had to look them up. Zip, super nice people. Most of the structures use what's known as zip on the outside, which is like an OSB with a film layer on it that you can tape the outside, and you can solve for air changes per hour and WRB, water resistant barrier, if you tape all the seams. So I know that's way over most people's head. Anyway, so it's an innovative product. Okay. But so those products you can buy for $54 a sheet. Because we're an energy efficiency company, we have had some partners come through and come through big lately. So back in the 70s and 80s, for those older farts out there like me, we built with what's known as Built Right buffalo board. It had no structural support to it, so you had to use metal bracing underneath it. So we got this metal bracing approved to replace OSB. So you take the OSB, don't throw that to the side, throw your 2x6 to the side, grab our stud, put this metal bracing on like this to solve for the lateral wind loads. And then we called up BASF foam and we said, we want this. This is known as neopor. And this has an R value of 5. OSB and plywoods have an R value of 0.55. So 900% better, you can have this. So on the 5.5 inch T-stud, that's 1.5 inch gap there. You put this on, now you have 2.5 inches of thermal break from the outside. This saved you 20% on your heating and cooling bill by putting that on the outside. I'll tell you in a second. Okay, so this building here, we're going to make 131% more energy efficient than what they were planning on for less money.
Wow.
Right? And we're going to solve for, we have more friends, and we're going to throw in the tape to tape up all the seams. They use this tape around all the windows indoors. So we're actually going to make them the world's most energy efficient commercial building right here in Ham Lake with these products. That'll be no extra money.
That's incredible.
Right?
Yeah.
Right.
So it was a combination of the T-stud, that metal bracing, that foam, whatever I forget what you called that foam.
Yeah, it's called neopor. This is another crazy invention. Okay. There is no blowing agent in this. They use doggone water.
Huh. Right.
This is light as a feather. We just bought 10 semi loads of this because we sold 19 houses in Sandpoint, Idaho. They're small. They're 1,200 square feet apiece. They're 2 stories, so 600 and 600, 2 boxes. They're I can't tell you a lot about them. The R value in the wall is 30. Air changes per hour below 0.25. I know how they're doing it. They're using our entire assembly with all of our partners. And at 1,200 square feet, you know what their budget is for gas and electric? All in, 100%, all in. $25 a month.
Wow. That's incredible.
Right.
Yeah.
$25 a month. Right. So we're helping them create an opportunity to reduce their heating and cooling bill by 75%.
Jeez.
We have those all over the country today, 75%. So we created the T-stud recipe. So if you can see my mom's recipe book over here, 1954, right? So we created our own recipe. So it's the T-stud, metal bracing, okay? Use neopor foam on the outside, grab some of our friends, right? Grab some of our friends. We called up U2 fasteners out of Thunder Bay, Ontario, right over the border where I go fishing, except for this year and last year. And so we're looking to, you can buy the T-stud by yourself. You can have your lumber yard call us up and we'll sell them to your lumber yard, or we'll ship to you direct. We'll sell you we'll put the OSB on the outside, put zip on, however you want to build your wall assembly, or we'll ship this whole package. The crazy part that we figured out is that we're only this tall in a semi. And we have 6 feet on top of us that we can top load and ship for free, right? So there's no cost because we already paid for the shipping. So we can send the metal strapping. We can send all the neopor. A 2,000 square foot house is only a 4 foot wide by 9, 10, 11, 12, 13, 14, 15, 16 foot long chunk, right? We can send your whole house. 2,000 square feet is just one load. And we send them out every day. And you build a structure that's 131% more energy efficient. But wait, there's more. We can actually send, we can send the 7 1/4 out because the costs are the same, except for this is a 2x4 instead of a 2x3. So we just added 2 more inches of lumber on top of this, or an inch. So this wall assembly right here is 21% less than Menards today to buy a 2x6 in OSB. This is 161% more energy efficient, and it's 14% less than going to Menards and buying a 2x6 and OSB.
Wow.
Right. So we're bidding on a company in Golden, Colorado. They're doing 300 unit apartment building. And right now we've helped them make the structure so tight that these are apartments. They're gonna have $15 to $10 to $15 a month in heating and cooling costs. That's it, in an apartment building. 10 to 15, that's it.
Jeez.
Right. And you know how much money we're gonna cost them extra? Goose egg.
Wow.
Nothing. We're no more money. And we made this structure that much more energy efficient. We just happen to have friends come around. We got them calling every day. Hey, can we be part of that process?
Yeah, right.
So I don't have to sell the TStud. I'm just excited to sell you energy efficiency so that we can reduce our carbon footprint, right? So if we continue on the path that we're at, and we're going to continue our doubling rate like this. But if we can say, hey, I want to build a more energy efficient structure, and especially if the doggone thing doesn't cost more money, I can drop that grid down to an angle like this, and I can extend our doubling rate out there by double.
That's really, really interesting. Now,
So,
you guys working closely as far as energy efficiency, working at all with companies that manufacture, windows or roofing materials, that type of thing, to kind of all be expand your recipe and be one big package on a energy efficient house. You mentioned a couple contractors that are kind of doing that already.
yep. Okay, so we have an interesting little tidbit. So I'll Marvin Windows, right, Minnesota.
Mm-hmm.
Okay, so in meeting with one of the owners, I only got two to choose from, so pick one. He said because we have the thermal breakthrough here, that we make the window more energy efficient because we don't have their wood jam directly or almost directly up against wood. We have this insulation value that slides in alongside of them. So they felt that their window jams themselves wouldn't expand and contract and twist anywhere as near as much because we make the wall assembly more energy efficient. Now what does that really do? I have no idea. None.
Elon Musk hasn't called you yet, has he?
No.
Oh, okay.
No.
It seems like something right up his alley. So, okay, to me, it seems like a no-brainer. Why wouldn't you build your house or structure with the TStud recipe? I mean, do you feel like you fit, most, if not all, construction type situations, or are there things that maybe this isn't the best option for?
I don't know of any that we don't work for.
Okay.
We have people who are trying to use our product. We have other products coming besides this. So this right here is a mini TStud, okay?
Mm-hmm.
And mini TStuds will be made completely out of plywood for different applications. So if you're going to let's say that you're going to remodel your house and you want to make your house more energy efficient, but you don't want to do it from the inside of your house, of course. You want to do it from the outside. So take your cladding, take your siding off, put on a little mini TStud. These are completely made out of plywood. So we make them in sheets, 4x8 to 4x16. We'll be producing these yet this year. So they're not for a HUD house or a one-level house, they'll probably work for on structural, but otherwise they're made for other applications, right? Every one of them is perfectly straight. So you can, every interior wall, you could do this. Every, you're remodeling your basement, you could do it, use them. We can make this side with treated plywood. So you can put this up against your concrete block wall to insulate, have a thermal break through your block wall. These will be 2.5 inches deep all the way up to 6. So we have had walk-in cooler people. Let's see, I got to go back. I got to finish one thought. So if you're going to do your remodeling work on the outside of the house, we're going to show one here yet this year on my house. So we're going to take off all the cladding, and I have built right on my house, and I have moisture problems on my house. I got the worst case scenario going on. And so we're going to put these on the outside in order to double the R value of the wall assembly itself. Okay. And so housing, this is fun. Making structures more energy efficient is fun. You could actually do this bigger. So if you want to fix your heating in your house, you can run ductwork on the outside of the house, and you can bury it inside of a nice little wall envelope if you want. You can fix your electrical from the outside so that you don't have to go on the inside. I got all sorts of people calling me for these things right now. And again, we've had to invent the technology to be able to do this, to load them fast enough. You're talking loading and using 96 dowels in 2 seconds.
Wow.
Okay, right? So this is nonstop inventions. We have walk-in cooler companies that want these 6 inches wide to make walk-in coolers 20% more energy efficient. It's a big number. RVs, fish houses, ice castle, you can get a hold of me, that's fine. We make fish houses more energy efficient by 20%. Actually, we built an accessory dwelling unit if they want to come here. We have a complete thermal break through the floor, the wall, and the roof by 99.2%. It's so energy efficient. So it's 16 feet by 9 by 9. There's no furnace made small enough to heat it.
You get a candle.
Don't 3 candles and a fart, because you have to have a little bit of combustion. Okay. But most of the time your body heat creates too much heat. That's how energy efficient it is.
Oh my gosh.
Right. So accessory dwelling units, they're called an ADU. So we built a mock-up ADU here so I can put all my TStud prototypes so I can get my truck back in the garage.
Yeah.
Okay. Typical Minnesota problem. We own too much crap.
Yeah.
And anyway, again, these are the most energy efficient structures known to man, and they don't weigh anymore. They don't weigh anymore. They don't cost anymore. We had Anderson Windows asked us if we could put these inside of a stile and a rail on a commercial window in order to make them structural, and we said yes. We've had other people ask us if we can just make what they have more energy efficient and structural, and we said yes. We actually have the 7 1/4 bare naked TStud will be certified to build 8-story buildings, and we're still 24 inches on center on the bottom floor, even with the snow load. That's how strong we are.
Jeez.
So we have another whole nother product line coming that we're in the process of building equipment on, that we're not going to get into today. It's a whole nother, it's craziness, but it's all in the same thing. So our goal has always been to build 25-story buildings, completely made out of wood, the world's most energy efficient structures with the least amount of carbon footprint. That's it.
Wow. Brian, I don't remember where I seen this or heard this, but I've heard that ADUs, these accessory dwelling units, are pretty much at every property in Hawaii, just because the cost of real estate down there is, extraordinary. So they're putting these, tiny homes, these accessory dwelling units in the backyards and renting them out to help pay the mortgage. And it seems like this tiny home idea has really started to catch on. It's becoming more and more popular.
Yep. We sold some bare naked TStuds to a company, for a tiny home company in St. Cloud or Little Falls or someplace up there. And we actually gave them enough. I haven't heard from them anymore. So if you're out there, send me an email and say hi. But there's 6 states that allow ADUs automatically up to 800 square feet in the backyard. Okay. So literally you can build them. I'll give you an idea. They're so energy efficient that you have to have it breathe, right? You have to mechanically have it breathe. So put a solar panel up on the roof, a small one, and a battery pack. And okay, there needs to be an invention. So if somebody wants an idea, I'm going to tell you what it is right now. Okay. No advertising for Starbucks here. So if this is an ERV, an energy recovery unit, I forget what ERV stands for at the moment. I need to get a pop can size ERV. So what happens is you need two of them because the structure is built so tight that a fart fan won't work because there's no place to draw air in from, right? So you put two of them. And this one pops air in at this same second that this one pops air out. And then it goes the reverse way the next time. So once every hour, it pops air in or pops air out, right? So somebody needs to invent these the size of a pop can, okay? Yeah. Right now, the smallest ones of these are 8 inches in diameter and they're about 14 inches long. They're all too big. It's just a little computer fan inside the thing. Somebody needs to invent them. So I gave you an idea.
Well, what's the danger of being too airtight? Is it you're going to be suffocating yourself?
Do you think you might run out of oxygen if you go in and you shut the door and you're there for 3 days? Guess what? Yeah. They're going to recover your body.
Okay, got it.
So did that answer that question?
Yeah, absolutely.
Okay. Right. So the whole idea is to make your structure so tight that the outdoor climatic conditions don't affect your utility bill.
Yeah.
Okay, and then you want to mechanically bring that air in and air out. So it's like a Venturi vent. Okay, yeah. You bring this cold, nasty air. We're in Minnesota. We're talking this way now. Okay, you bring this cold, nasty air in, and at the same time, you want to have the nice the money that you spent your air on here. Cross that to pre-warn this cold, nasty air coming in, so that you don't dump. It's like opening up your door, right? You don't want to dump in 35 below into your house and that you have to now heat it, right?
Right.
So most houses in Minnesota, existing houses, are 5 air changes an hour. Your fart must be pretty bad if you got to do it 5 times an hour. I have no idea, but that's how we built. Nobody ever knew any better. Nobody knew what the benefit was of having airtight houses. Well, I guess we did in Minnesota because in the late 80s, 90s, we did a category 1 construction. We made them too tight. And I want to tell some stories, but I got to be careful. We chased out every stucco manufacturer out of Minnesota, okay, including Scandia Stucco, super nice people. And so we built structures so airtight that if you had a pinhole in your wall, it's like you go hang your picture on the wall, you poke a hole in the wall. They got these stories all over the country. Guess where all the moisture in your house goes? Out that pinhole right there, and it rots out the wall, right? So Minnesota, they want you to put poly on the inside wall, and they tell you, this is an airtight barrier, and you got to make all these airtight structures. But they never told the homeowner, oh, by the way, you can't ever hang a picture on your wall unless it's on one of them glue sticky things, right? But as soon as you poke a hole in that wall, you broke your air barrier, and now you have a path for moisture to enter and to leave your structure and get into that wall assembly. I have seen, this is a long time ago, not today. Okay, so I'm not trying to scare anybody, but I've seen windows rot out on the corners because the only place they didn't control the air is through the corner. So the air went out the corner of your window and it rotted out the corner, and then your stucco fell off your house. They said that was the stucco people's fault. It was not. The state of Minnesota screwed up. They made they made energy efficiency so brutal in Minnesota, kind of as a test, I guess. I don't know what they were thinking, but we had all sorts of damages. In order to vent the moisture out of your house, when you took a shower, you had to open up the window a half inch or a quarter of an inch anywhere in the house because they were built too tight. Wow. So now you have to mechanically vent your house, but at least you're controlling when you write the checkout and how much air goes in and out that wall, in and out to the outside. Well, that's fine. Doesn't cost very much money. So build them as energy efficient as you can in order to control your utility bill. It's like that.
Yeah, there you go.
Yep.
Brian, we're coming up almost on an hour and a half here, so I should probably wrap this up. Let's say I'm a builder and I'm interested in trying out the TStud, or I'm a end user consumer, and I want to put up a house and I want to, recommend the TStud. How does somebody find out more information or contact you, Brian?
Okay, TStud.com, just the letter T and then stud. So TStud.com. If you want to order, it's sales@tstud.com. And pretty simple. Just go through there. If you want to get a hold of me specifically, just send an email through there and I'll respond. And otherwise, every ounce of information that you can possibly think of is on tstud.com. So our goal as a company is to rewrite our goal as a company. So we made the new Lincoln log. That's what we did.
Yes, and you did a great job with it. And I gotta say, your website is really informative. You got some good videos and content on there that I think a lot of people find a benefit as far as how does it work and why to use it and so on. So
yeah. So my daughter does all the branding and she lives in Blaine. And we just hired a CFO out of Woodbury. He just sold his 4th company. So we feel quite blessed there.
okay.
And my son-in-law is the president, and they just sold their company, Patriot Converting, up in Elk River, Minnesota.
Okay.
We're all spread out all over.
Yeah.
We do Zoom meetings all the time.
Okay. Yeah, that's pretty cool. Again, as a family business, that seems to be a common theme lately with people that I'm interviewing.
Yeah. Yep.
Yeah. All right, Brian. I appreciate your time, man. I think the future's bright here. It's an awesome product. I wouldn't hesitate using it on my own house. And I wish you all the luck, man. And I appreciate your time today.
I'm sorry it took an hour and a half.
Oh, it's good. It's been a good hour and a half. I appreciate it.
Yep. Yep.